In this video, we want to look at the secant and cosecant parent functions, the most basic secant and cosecant graphs. And the first one we're going to look at is the secant. So y equals the secant of x. And the outputs of secant are the reciprocals of the cosine outputs. Secant and cosine are reciprocals. So what we're going to do is we will use our cosine graph, look at its reciprocals, and get the secant graph, okay? So let's look at the, in red, let's look at the cosine graph. And when I say cosine graph, let's say specifically secant of x is the reciprocal of cosine of x. So let's look at y equals cosine of x from 0 to 2 pi, okay? So in red, the cosine function from 0 to 2 pi has an amplitude of 1, an average value of 0, and it starts up here at 1 and at, at the angle of 0. It starts at 1 at the angle of 2 pi. It ends at 1 because that's one complete cycle. So it starts and ends in the same place. And then halfway between at pi, it's at the bottom of the graph, its minimum value, -1. And then halfway between 0 and pi, it's between 1 and -1, so it's at its average value of 0. And between pi and 2 pi, it is back at 0 again, okay? And it curves kind of like this. So this is our cosine of x function from 0 to 2 pi. It's one complete cycle. So if we were to look at the reciprocals of the outputs of this function, then the secant graph is what we'll get. So the first thing is, right here, cosine has an output of 1, and the reciprocal of 1 is also 1. So I get, for my blue secant graph, I get the same point. Similarly, over here where the output is 1. At the bottom of the graph, cosine outputs -1. The reciprocal of -1 is also -1, so that point is also common to the secant graph. It starts to differ now, though. For example, right here, the cosine function outputs 0, a y value of 0. The reciprocal of 0 is undefined. So what you get for your secant graph is you get an asymptote. This vertical line that your graph can't touch, but it approaches. And the same thing over here where cosine is 0, secant is undefined, okay? So you can start to see some differences now. Furthermore, in this region right here, the cosine graph starts at 1, and then the y values are getting smaller and getting closer to 0. You might end up with a y value of 1/2 right here, or a y value of 0.1 way down here. Well, when you take reciprocals of really small numbers, you get really large numbers. So what that tells us about the secant graph is where cosine gets smaller, 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 secant is going to grow and get bigger, 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 infinitely forever, approaching this vertical asymptote. And the same is true down here. We're still getting, if I start at this valley of the graph at -1 and move this way on my cosine function, my y values, the numbers are getting smaller, right? They're getting closer to 0, but they're negative numbers. When I take the reciprocal of a very small negative number, I get a really big negative number. So my graph of secant does this as well. And you can imagine the behavior is consistent throughout. And so what we get here in blue, I'm shading it in yellow now, is the secant of x function from 0 to 2 pi. That's one complete cycle. And if I were to continue this pattern, you could see, then I would have to take this piece, this is the beginning of a cycle, and start another cycle here, and you would get a full U shape, right? So let me do that as a dashed line so you understand that what's in yellow is a complete cycle. But if I continued it, I would then repeat this asymptote. I would repeat this downward shaped U to get another piece. Then I'd have another asymptote, and then I'd repeat this yellow piece up here. And now that would be, the yellow is one complete cycle, then the next portion is 2 complete cycles, and I could continue that as many times as I want because the secant function does repeat itself, just like cosine does. And that makes sense, since it's the reciprocal of cosine. So this is one complete cycle of secant. Now, if we look at cosecant, it should go much faster now. Cosecant is the reciprocal of sine, of the sine function. So let's look at the sine of x, y equals the sine of x from 0 to 2 pi as well. So here's 0, here's positive 1, negative 1 on the y-axis. Here's 2 pi. The sine of x function starts at 0, and at the end of its cycle is also 0, since it's a complete cycle. And then in the middle of its cycle, it reaches its average value again. And then halfway between 0 and pi, it reaches its maximum value up here at 1. And halfway between pi and 2 pi, it reaches its minimum value at negative 1. And so the sine function looks like this. It's a wave, just like the cosine function, but instead of starting at 1, it starts at 0. Okay? Now, the reciprocal, the cosecant function, is going to be much like the secant function was. I use the reciprocals of my y values. So my sine function here is 1, and the reciprocal of 1 is 1. So my cosecant graph is going to have this point in common with my sine graph. And the reciprocal of negative 1 is negative 1, so they will also share the point down here. In the places where the sine of x function is 0, the cosecant function will be undefined. So now my asymptotes will be in a slightly different place than my secant function was. By the way to spell asymptotes is like this. It's kind of a strange word. And then again, your cosecant function up here in the blue point is not going to go down like the sine function because it's the reciprocal. The reciprocal of small numbers are big numbers. So the cosecant graph is going to get big as it approaches those asymptotes. And it gets big in the negative direction as well. So for a cosecant function, one complete cycle of a cosecant function, it's a little more cohesive than a secant function. You get two complete U shapes. For the secant function, you get half of a U, and in the middle you get a full U, and then at the end you get the other half of the first U. Okay? But they are the same shape if you were to continue repeating it forever. And then this, of course, is another one complete cycle. And this is of the cosecant of x function. And then this pattern would repeat. You'd have an upward U next, an asymptote, a downward U, etc. to get more cycles. So, for a complete cycle for secant and cosecant, you have to rotate through 2 pi radians, just like you do for sine and cosine, because they're reciprocals. And as we saw here, we will typically use the cycle from 0 to 2 pi to represent the shape of these functions. Secant and cosecant do not have amplitude or average value, right? The red sine function has an amplitude of 1 because it keeps oscillating through 0 and it deviates from that by 1 unit up or down, so that's an amplitude of 1. Now secant and cosecant go up and down forever, so there is no amplitude. There's also no average value because it doesn't ever hit the middle value of 0, so no average value. And those are the standard secant and cosecant parent functions.